A particle p moves in a straight line such that its acceleration is 12t minus 6 meters per second squared. At t equals 0, it has a velocity of 4 meters per second, and it is 8 meters from O. So we have A is 12t minus 6, and we have the information that v is equal to 4 when t equals 0, and that x is equal to 8 when t equals 0. We want the velocity of the particle when t equals 3. So we first need an expression for the velocity. We know that a is equal to 12t minus 6. So v is going to be the integral of a dt, which is the integral of 12t minus 6. This gives us 12t squared divided by 2, take away 6t plus a constant. Tidying, this is 6t squared minus 6t plus c. We can use the information that v equals 4 when t equals 0 to work out the value of c. We know that 4 is equal to 6 times 0, which is 0, take away 6 times 0, which is 0, plus c. So therefore, c is equal to 4. v then will be 6t squared minus 6t plus 4. So we know the velocity is 6t squared minus 6t plus 4. We want the velocity when t equals 3. So v is going to be 6 times 3 squared. Take away 6 times 3 plus 4. 6 nines are 54. Take away 18 plus 4. And this works out to be 40 meters per second. Now want the distance of the particle from O when t is 4. Displacement is going to be the integral of velocity, so the integral of 6t squared minus 6t plus 4. This is going to be 6t cubed over 3. Take away 6t squared over 2 plus 4t plus a constant. And tidying, this gives us 2t cubed. Take away 3t squared plus 4t plus c. We know that x equals 8 when t equals 0. So 8 is going to be equal to, everything here will be 0 except the c. So 8 is equal to c. Therefore x is 2t cubed minus 3t squared plus 4t plus 8. So now, when t equals 4, x is going to be 2 times 4 cubed, take away 3 times 4 squared, plus 4 times 4, plus 8. And this is going to be 104 meters.